Today, every time you load a web page or stream a video, you rely on a routing architecture designed in the 1970s. The TCP/IP protocol handles all of your data exactly like a postal service sorting millions of blank boxes. It routes traffic based on geographic coordinates, the IP addresses of the sender and the receiver. The network moving the package is completely blind to its actual contents. This location-based model is increasingly mismatched with how we use the internet, where over 90% of traffic is content retrieval. We are typically asking the network for a specific piece of data, regardless of which physical server it currently sits on. This leads to massive inefficiencies. We secure the connection rather than the data itself, and routers cannot distinguish a critical medical alert from a routine social media update. This is the architectural pivot for the 6G era. On the left, traditional TCP/IP searches for a physical host. On the right, MemNet uses Information-Centric Networking to route traffic based on a hierarchical name assigned to the data. By identifying data by its name, the network can present information as structured semantic primitives. This provides the organized inputs that AI models require for real-time reasoning, rather than a raw, unorganized stream of bits. MemNet communication uses two new primitives. An application broadcasts an interest packet, a request for a specific data name. The network finds the nearest data packet. It contains the content and a cryptographic signature, following the interest's trail directly back to the user. Every MemNet router also contains a content store. This is an in-network memory cache built directly into the routing hardware. If thousands of people request the same file, the data doesn't cross the backbone thousands of times. The first router that retrieves the data saves a version in its content store and serves its own copy to every subsequent user. Distributing memory into the routing fabric eliminates backhaul bottlenecks by turning the network into a globally distributed content delivery system. Because MemNet routes by name, it can assign priority based on the specific type of information being carried. This allows the network to natively guarantee performance for critical data. In scalable video coding, video splits into a required base layer and optional enhancements. The router places the base layer in a high-speed protected lane. During congestion, it drops enhancement packets, while the base layer continues uninterrupted. The stream never stops. For life-critical information, MemNet uses a TSN proxy. This translates ICN data names into time-sensitive networking reservations, which are guaranteed hardware paths across the network backbone. Fusing data names with time-sensitive networking creates zero-congestion hardware contracts for critical data, a level of reliability that was previously impossible on standard Ethernet. This architectural shift also changes how the network defends itself against distributed denial of service, or DDoS attacks, where massive floods of garbage traffic are used to crash systems. MemNet integrates the marine algorithm directly into the hardware of the router. It identifies anomalies in O1 constant time, performing detection at line rate speeds. Instead of heavy processing, the algorithm monitors traffic behavior by analyzing jitter, the timing deviations between packets. A DDoS attack is a chaotic explosion of erratic jitter. The switch instantly drops these malicious packets into a background queue before they tax the system. Treating jitter as a behavioral signature allows the network to identify and neutralize threats at the hardware level. This efficiency extends to edge devices through a power-aware strategy that utilizes multiple radios. A sensor can stay in a low-power sleep state, using only a tiny LoRa radio to listen for an interest ping. It only wakes up its high-bandwidth Wi-Fi chip when there is a specific request for a heavy data payload. To maintain security in these large-scale meshes, MemNet integrates a peer-to-peer reputation system directly into the routing logic. Routers constantly evaluate their neighbors. If a node is identified as malicious or refuses to cooperate, the network lowers its reputation score and automatically avoids it. MemNet transforms telecommunications from a system that blindly transmits bits into a semantic substrate that natively prioritizes and authenticates information. This 6G infrastructure coordinates data based on its internal semantic value, allowing the internet to function as a globally distributed, self-aware memory.